morning, students. Let us begin our today's class on the chapter Is Matter Around Us Pure? Previously, we had discussed about pure and impure substances and the types of pure substances. So today, we are going to discuss about the types of mixtures, that is homogeneous mixture and heterogeneous mixtures, including examples with special reference to alloys. So let us begin. Students, as we are already knowing that mixtures are constituted by more than one kind of pure form of matter known as a substance. So depending upon the nature of the components that form a mixture, we can have different types of mixtures. So for understanding the types of mixtures, let us first discuss one activity. I hope you have understood what are mixtures. So let us proceed. So what is the activity? So the activity is like this. Suppose we have four groups of students as group A, group B, group C and group D students. Now group A students has been given a beaker containing 50 ml of water and one spatula full of copper sulfate powder, and they were asked to mix them properly. Now again, for group B students, they have been given 50 ml water in a beaker and two spatula full of copper sulfate powder, and again they are also asked to mix them. For group C students have been given different amount of copper sulfate and potassium permanganate, and they are also asked to mix them. Similarly, group D students have been given a different amount of copper sulfate powder and crystals of potassium permanganate. So what are their observations? So the observation is like this. Groups A and B have obtained a mixture which has a uniform composition throughout. Why? Because they have been given 50 ml of water and one spatula full of copper sulfate powder. And on the other, for group B, they have been given 50 ml water and two spatula full of copper sulfate powder. So they have obtained a mixture which has a uniform composition throughout. So such mixtures are called homogeneous mixtures or solutions. Some other examples of such mixtures are salt in water, sugar in water. So after comparing the color of the solutions of the two groups, though both the groups have obtained copper sulfate solution, but the intensity of color of the solutions are different. This shows that a homogeneous mixture can have a variable composition. So this is the observation for group A and group B. Now group C and D have obtained mixtures which contain physically distinct parts and have a non-uniform composition. So such mixtures are called heterogeneous mixtures. Mixtures of sodium chloride and iron fillings, salt and sulfur, and oil and water. These all are the examples of heterogeneous mixtures. So after discussing this activity, we can conclude that homogeneous mixtures are those which has a uniform composition throughout. And in this kind of mixture, you cannot distinguish the components. For example, you can see these are the examples of homogeneous mixture: puree, coffee, milkshake, chocolate, tomato soup, orange juice. All these are the examples of homogeneous mixtures because they all are having uniform composition throughout the mixture. So proceeding towards the heterogeneous mixture. From the above activity, we can also conclude that heterogeneous mixtures are those which contain physically distinct parts and have a non-uniform composition throughout. And in this kind of mixture, you can distinguish all the components. For example, salad, fruit salad, pele, milk and cereals, chickpeas, all these are the examples of heterogeneous mixture because they contain physically distinct parts and they are also having non-uniform composition. So I hope the basic things for homogeneous and heterogeneous mixture is clear to you. So now a special topic, alloys. You must have read about alloys in your previous classes. So what are alloys? Alloys are mixtures of two or more metals or a metal and a non-metal, and they cannot be separated into their components by physical methods. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have a variable composition. For example, if we are considering brass is a mixture of approximately 30% zinc and 70% copper. So, for example, steel as well. For example, you can see gold, and you are knowing that here 14 karat gold, 10 karat, 18 karat gold. So 24 karat gold is the purest one, having 99.9% purity. And for 18 karat gold, in 18 karat gold there is 18 parts of gold and 6 parts of another metal which is forming an alloy. So these carat, we are writing this carat for in terms of calculating the purity of the gold. So we can say that alloys, most of the alloys are homogeneous in nature. So proceeding further towards some differences between homogeneous and heterogeneous mixture. So basically we are knowing that homogeneous mixture having uniform composition throughout, and heterogeneous mixture on the other hand, they don't have a uniform composition. Again, for homogeneous mixture we can say that their components cannot be separated by filtration but they can be separated by distillation method. Again, for heterogeneous mixture, their components can be separated by simple filtration method. For homogeneous mixture, examples you are knowing: salt, water mixture, sugar, water mixture, means salt solution, sugar solution. These all are the examples of homogeneous mixture. And on the other hand, for heterogeneous mixture, mixture of sulfur powder and iron fillings. You must be knowing sulfur powder and iron fillings, kerosene oil and water, and we had discussed more examples of both the types of mixtures. So let us watch a video over this topic for grasping more and more examples of homogeneous and heterogeneous mixture.
Homogeneous mixture and a heterogeneous mixture. But what do you think the difference is between these two types of mixtures? A homogeneous mixture has visibly indistinguishable parts. All you can see is one clear solution. In a heterogeneous mixture, you can see multiple distinguishable parts. A homogeneous mixture has uniform composition. The composition is the same everywhere in the mixture. And a heterogeneous mixture is not the same. The composition can vary by position. So let me give you an example. Salt water is a homogeneous mixture. When you look at salt water, all you could see is one clear solution. you don't see two distinguishable parts. You can only see one visible part. Now, what about oil and water? Is that a homogeneous mixture or a heterogeneous mixture? By the way, keep in mind, a mixture is a combination of two or more pure substances. Oil and water do not mix. You can visibly see two distinct parts. Now, water is more dense than oil, so the water layer is going to be below it. The lighter oil layer is going to be above it. So because oil and water do not mix, you can see it's a heterogeneous mixture. You can see the two visible parts. Now, what about brass? Is brass a homogeneous mixture, or is it a heterogeneous mixture? Brass is a homogeneous mixture. Brass is an alloy. It's a solid solution of zinc and copper. And these atoms are distributed uniformly throughout the material. So most alloys tend to be homogeneous mixtures. Their composition tends to be uniform. Now, what about sand and water? Is that a homogeneous mixture, or is that a heterogeneous mixture? Sand and water is a heterogeneous mixture. You can clearly see two distinguishable parts. Salt dissolves well in water, so basically you don't see the two distinguishable parts. But sand doesn't dissolve well in water. If you put sand in water, the sand will just fall to the bottom, and you could see the sand in the water. You could see the two distinguishable parts. So sand water, or sand plus water, that's a heterogeneous mixture. Now, what about air? Is air a homogeneous mixture or a heterogeneous mixture? Air is a homogeneous mixture. You don't see visible parts in air. You don't see red air or blue air. It's just air. It's uniform in composition. Air contains nitrogen gas, oxygen gas, argon gas, water vapor, carbon dioxide, and all of these gases, they're distributed throughout air uniformly. So air is a homogeneous mixture. Now, what about rubbing alcohol? Is that a homogeneous or a heterogeneous mixture? When you look at a bottle of rubbing alcohol, do you see one clear solution, or do you see a mixture with two distinguishable parts, two or more distinguishable parts? A bottle of rubbing alcohol looks like one clear solution, so therefore, it's a homogeneous mixture. Now, what about tossed salad with ranch on it? Would you say that's homogeneous, heterogeneous? How would you describe it? If you have tossed salad with ranch, it's a mixture, but you could see the ranch, you could see the green salad, you could see the distinguishable parts, and so that would be a heterogeneous mixture. So it really comes down to what you could see. If you can see just one part, one clear solution, that's a homogeneous mixture. If you could distinguish two parts, then it's a heterogeneous mixture. In the case of sand and water, you can visibly see the water, and you could visibly distinguish it from the sand. So that makes it a heterogeneous mixture. So
students, I hope now all of you have understood the two types of mixture, that is homogeneous mixture and heterogeneous mixture. So today we have learnt about homogeneous and heterogeneous mixture, including various examples from daily life. So thank you students.